Hi everybody, my name is Mark Mandel, and I'm a developer advocate for Google Cloud for Games. Today, I'm going to talk to you about scaling globally with game servers and Agones. So today, we're going to talk about dedicated game servers for large-scale multiplayer games. If you're not familiar with dedicated game servers, very quickly, what they are is a full simulation of what's happening inside a game, usually running somewhere in the cloud. And what happens is the people who are playing a particular game session will all connect to an individual dedicated game server process. Usually they'll send things like, hey, I'm moving forward, or maybe I did an action like fired a rocket. And it's up to that dedicated game server to basically be the authority of what's happening inside that game and send that information back to the players so that they know exactly what's happening inside the game. This is really important for large-scale multiplayer games because it enables people to have a lot of control over the latency experience that people have with these real-time games. This is important because you have geographic control over exactly where your dedicated game servers exist, because players around the world are going to play your game. So if you have very low latency requirements, which many real-time multiplayer games do, you can put it in a particular place around the world so that you can have control and have knowledge over exactly how fast the information is going backwards and forwards from these dedicated game servers. So that sounds simple in practice, right? But orchestrating these thousands of machines and potentially thousands of dedicated game server processes around the world is essentially a tricky problem. There's a lot of moving parts that you need to look at and a lot of things that could potentially go wrong. So that's really what I want to talk to you about today. How are we solving that problem with Google Cloud Game Servers and the Agones project? So let's start from the foundation, some things you've probably already heard of. So many of you are probably already familiar with the Kubernetes project. If you're not, it's an open source project initially started by Google that's built for running processes or software processes over a large number of machines inside a cluster. Kubernetes is fantastic. You can come to Google Cloud, run it on our GKE platform. You can also run it wherever you want to run it as well. This is super useful for game servers because it means then that you can put your game servers in places that your players are, and players show up in all sorts of interesting places around the world. So Kubernetes is a great foundation for if you want to run game servers. So Agones is another wonderful project you may necessarily have heard of. It's an open source project that extends Kubernetes so that Kubernetes understands how dedicated game servers work and what a dedicated game server lifecycle is and how it is managed. It's also great that it's open source, much like Kubernetes, because this again means that Agones can be run wherever your player base is, or potentially inside your own studio or inside your own on your own laptop as well. It's a great project that's been running for several years now and went 1.0 back in September. It has a variety of functionality that is super useful specifically for running dedicated game server workloads, including native integration with Kubernetes tooling, auto-scaling capabilities, SDK integrations with things like Unreal and Unity, a bunch of cost optimization functionality, as well as metrics and dashboards so you can see exactly what's happening inside the fleets of game servers that you're running inside of Agones. But we were talking previously. We were talking about how we want to run this in a global network of distributed game servers that run around the world. And that's where things do get hard again. Agones is a fantastic project, but it really works primarily within a singular Kubernetes cluster. So if I want to cluster machines in, say, a region or a zone inside, say, Google Cloud, this is fantastic. But if I want to run these in multiple regions around the world, things get a bit more complicated. And this is where we step into Google Cloud Game Servers. Google Cloud Game Servers is a management layer that sits on top of open source Agones. It provides a wonderful set of functionality and features that makes it easy to orchestrate and scale multiple clusters of Agones around the world, while still not locking you into a specific vendor package, and also giving you a lot of flexibility and power to be able to run your game servers in exactly the way that you want to. So, how does this look? And what do we need to do to get started? So we're going to get stuck into that. So at a high level, what concepts do we have? So you're probably already familiar with the Google Cloud project. Nothing there has changed. Our best practice here is saying that you probably want a singular project for a singular game title and environment. So if I have a game X and I have it in production, that is generally a project. Next, we have game server clusters. These are simply Agones clusters that have registered themselves with Google Cloud Game Servers so that Google Cloud Game Servers is aware of them. You have full access still to that GKE or Kubernetes cluster, so you can do extra stuff in there if you want, up to you if you choose to, but it's simply just that Kubernetes cluster that is registered. But we also need a way to organize those clusters together. For example, I might want to have a set of clusters that are in US Central to help support my US player base. I might just say, okay, cool. I want to group those together so that they're essentially the same from a latency perspective or an organizational perspective, so that all the players I know could choose any one of those clusters that are sitting in US Central. We've called that concept realms. That is simply a user-defined grouping of clusters such that we know that the latency requirements for those clusters are going to be basically the same for any players that are connecting to them. From there, we have game server configs and deployments. That's how we can set up our fleets and auto-scaling capabilities and then deploy them out either globally or even just to particular sections of our global fleet of game servers. It gives us a lot of control, and we're going to dig into that a little bit more. So just looking at it in a different way, here's a really great example of this particular game X we were just talking about. So here we have multiple realms. We have a US realm, we have a Europe realm, and we have a Japan realm. And we also have this working with multiple clusters within each of the realm. Here you can see in the US realm, we have a GCP cluster, we have an on-prem cluster. Inside the Europe realm, we have a GCP cluster and another cluster on another cloud. And in Japan, we're just using GCP because for there it makes sense. What we're then able to do is apply these Google Cloud deployments and configs across all the realms so that we can manage these global fleets of games clusters and provide a wonderful experience for all our players, regardless of where they are. So how does this work? How do we get started? Pretty straightforward. First step, start with open source Agones. The migration path from Agones to Google Cloud Game Servers is actually really easy. So you can definitely get started there if that's a place you want to get started. The next step from that is you need to register that cluster with the Google Cloud Game Server system. To do that, you need to turn on the Game Services API, which is a one-click process. You then need to define your realms within your system, how you want to organize each of these clusters into location-based areas. Then, from there, define your configs and define your deployments. How do you want your fleets and auto-scaling capabilities to be pushed out across all of these clusters? That's really about it. It's a multiple step process, but it's relatively simple. And if you're already familiar with Agones, you're going to find it really familiar as well. So let's get stuck into an actual demo so I can show you exactly how all this works. So let's actually run some game servers. Earlier, I've prepared 4 clusters that are set up. I have 2 in Europe and I have 2 in the United States. You can see these here. They're just plain old Google Kubernetes engine clusters. Nothing special about them, except for the fact I've already installed Agones on them, and I've already coordinated them with their realms. So let me give you a preview of what the dashboard looks like for Google Cloud Game Servers. So here you can see that I've set up 2 realms. I've set up 1 in Europe, and I've set up 1 in the United States. And I've registered each of these clusters appropriately. So you can see the 2 here inside Europe, and the 2 here inside the United States. That's really all I had to do. Right now, I don't have any game servers running on them, but I'm ready to go. Everything is ready for me to run some game servers. So I'm going to come over here to my trusty Cloud Shell that I already have set up and connected to everything. I've got it connected to one of my clusters. So if you're familiar with Agones, I can do kubectl get game servers. And right now I don't have anything, but as you can see here, my Kubernetes cluster does understand how game servers work. So we want to deploy some game servers via a fleet, which is a big set of game servers, to all the clusters that I have inside my set. So I'm going to actually open my editor. We have here what we call our fleet configuration. It's going to be part of what we call a config for Google Cloud Game Servers. So if you've used Agones before, this probably looks really familiar. Here we have our image for what we want to actually run as our game server, how many of them we want to run. So here I have a replicas of 2. And we also have a version, which is right here. We're just going to put a tag on it called version 1.0, put this label on it so we can see some things as we go forward. So the first thing I actually need to do is set up what we call a deployment. So I'm just going to close this editor right now. So Google Cloud Game Servers, we're just going to do a deployment. We're going to create it, and we're just going to call it SDK. SDK because the game we're actually going to be using is a game called Super Tux Kart. It's a really fun multiplayer racing game. that some people may already be familiar with because it's been around for a while. It's really cute and adorable. So a deployment is basically a placeholder for where we want to put our configurations, and we want to organize them, and then we can apply from there, which we'll see in a minute. Next, we're going to create our configuration. So let's do that. Configs, create. We're going to attach it to our deployment, which is SDK. We're going to pass in our fleet config file, which is fleet-v1.yaml. And we're going to call it v1. Pretty simple stuff. Now, this actually isn't going to apply anything to our cluster yet. Nothing's been created at this stage. So if we want to actually apply it, we're going to need to actually do a rollout action. This gives us a lot of steps in between, and we're going to look at an extra one here that gives us a lot of control and a lot of warning and a lot of preview on exactly what's going to happen inside our cluster, because we're dealing with a global scale system here, and we really don't want to mess this up. So let's do our rollout. So we're going to look at our deployments. So we have this SDK deployments. We want to apply a default deployment, roll update, rollout. So we want to roll it out. We're going to say our default config is v1. And we want to do a dry run. And we want to do it to our SDK deployment. So what does this mean? So we're saying we want to do a rollout. We want to push this out to all the clusters that we have. But we want to dry run it first. So we want to be able to have a look at exactly where this is going to go. So we have a lot of feelings of confidence and safety in what it is that we're doing. So here we can see we have a config v1, and we can see that it's being applied to each of the clusters that are around the globe, all 4 of them, which is exactly what we want. So we're like, great, that's awesome. That's exactly what we want. So now let's run that again with no dry run. And we'll see that's now going to start pushing it out to all the clusters we have. So that fleet that we set up previously with that v1 config of that fleet, that's now going to start rolling out to everywhere. We're going to see 2 game servers. So if we actually have a look in this US cluster, we can see that we have 2 game servers there. We can actually see that it has v1 in the title there as well. If we want to have a quick look at it, we describe our game server. We can see all kinds of interesting information. We scroll up here, we can see that version label, that 1.0 version. And if we scroll down, we can also see that we have the right image there as well. So that's looking pretty good. Now, to prove to you that it's running in multiple clusters, let's actually connect to our US2 cluster and do the same thing. So grab that information, copy it, connect away. If we look at our game servers there, we can see we also have 2 game servers there as well. So you can see, right, like we've been able to really easily set up these fleets that run across multiple clusters around the globe with only 1 command, and also do a preview of it as well. So we're going to do an allocation next. Part of both open source Agones and Google Cloud Game Servers working together is multi-cluster allocation system. We actually have a gRPC endpoint that gets used for this, which is why I'm using a script to make that easier, that is authenticated with some certificates. And what this is doing is it's going to hit one of the endpoints on one of the clusters. The one that I'm actually connected to right now is US2. It's going to do an allocation. For those of you who aren't familiar with Agones, an allocation is basically a special thing that says, okay, give me a game server and then mark it as allocated so that I know that there are players playing on that particular game server, right? And don't delete it. We don't want to delete game servers where players are playing. They tend to get mad when that happens. So we got back a game server, which is awesome. Let's actually kubectl get game servers. We can look at it this way, which is super nice. We can see one of those is allocated. I'm going to actually mark both of them as allocated right now, just for convenience, and I'll show you why in just a second. So let me grab that one we previously allocated, and we're actually going to play a game. So this will be fun. What do I want? I want this here. Boop. So we'll pop over to SuperTuxCut in my command line, and we'll click Run Game. Let's pop that up. So let's connect to our allocated game server that we just set up. We'll connect there. Excellent. So that's connected. I'm connected. I probably need some friends to play with though. So why don't we set up some AI bots that will also have that running. So here we go. Here's a script that I have running here that will put 3 friends, allow me to play with some people. Run that. Wonderful. Now we can see we have these 3 bots that have joined me in this game. And let's start a race. So I'm going to play as Puffy. I will choose that track. That'll give me a couple of seconds to count down. But this is running directly against the dedicated game server we have running on one of our Agones clusters that is being managed by Google Cloud Game Servers at this stage. So you can see it's actually running against US Central, and I'm able to play a game. So here I am. We're just waiting for the green light to go ahead. Excellent. Now I'm driving. And so I'm playing this game against several players who are also racing against me, all running from my local machine. It's a super cute game. I love Super Tux Kart. We won't play for too long. It's fun. Okay, that was cool. All right, I'm gonna shut that down. So you can see that a game's actually playing. So coming back to Cloud Shell, if we look at our game servers, we'll see now that we still have one allocated and one ready. So Super Tux Kart is great in that once we've all disconnected, it'll actually shut itself down. If you're not familiar with Agones, it's going to make sure that we have the right number of game servers ready and available for us. And we've said we want 2, so 2 is going to be up. But we clearly have another player still playing with that allocated game server that's still sitting there as well. And we're going to come back to a little bit later as well. Okay, so we have those 2 game servers, but maybe we have a new update. Maybe we have another game server that also wants to come up in a different way, or with a bug fix, or we want to test out maybe a new level or something like that. So we may not want to roll that out to the entire globe all at the same time. Maybe we want to do a test. So in this particular instance, what we're going to do is we're just going to roll that out to Europe first, see how that goes in that player base, and assuming everything goes fine, then we're also going to roll that out to the rest of the world. So we have a v2. So if we come back to our editor, let's have a look here. Excellent. We have this v2 config. So here we've said, okay, we actually want to have 5 replicas rather than 2. We're going to put a version 2 label on it. Everything else for this demo, we're going to keep the same, but you can imagine you might have a whole new version of this game server that you want to push up. So to take this live, what we're going to do is do exactly what we did before. Configs, create. We're also going to attach this to our SDK deployment. We're going to have our fleet config file of fleet v1.yaml, and we're going to call this, fleet v2.yaml, and we're going to call this v2. So we'll create that. So how then do we do that sort of overwrite sort of situation where we just want it to run in one particular cluster? So we pop back to our editor. We can write this thing called an override YAML, where you can see here where we can write this thing called a realm selector that says, oh, okay, for these particular realms, I want to have this particular config version. So here we're going to say, okay, we want the v2 config. Let's actually apply this deployment, but with the override we had previously. So we are going to do a update rollout. Our default config is still v1, but our config override is override.yaml. We still want to do a dry run. We want to see what's going to happen there, and we're applying it to our SDK deployment. There we go. So this is actually kind of interesting here. So we can see here in our US realm, we will have that v1 set up just the way it was before. Nothing changed there. But we can see here in our EU clusters, in our EU realm, we have v2, and that's available. So let's actually roll that out. Do no dry run. That's pushing out. So we're still connected to that US cluster. If we want to have a look at what's available there, game servers, we should see that it's all the same. Yeah, we still have that allocated game server. We can still see we have v1, and that's available. So that's pretty cool. But if we pop back over to, say, an EU cluster, let's connect to that. There we go. And we have a look at what game servers we have available here. Suddenly we can see that we have both 5 game servers, not like the 2 we had previously, and we can see here that they're the v2 instance, which is super nice. So we have a lot of control here exactly how we want these game server fleet instances to be run around the world. Let's do one more thing. I just want to do one more fun thing, which is let's push that v2 instance all around the world. We can do that very simply to what we've done previously. So we have a deployments. We do a update rollout. We say our default config is now v2. We are actually going to clear our config overrides. And again, we'll do a dry run just to check to see everything's okay. And here we can see, okay, we have that v2 instance running across all the clusters that we own. So let's actually run that. Updating rollout. Now I want to show you one more very important thing. We come back to that US cluster we were connected to previously. Remember that one we had allocated, that we used the multi-cluster allocation to get set up and ready to go? We can have a look here, and if we do kubectl get game servers, that allocated game server from previously, that's still there. This is very similar exactly to what Agones would do previously. Those allocated game servers are essentially very important. We don't want to interrupt those, and we don't do that here as well. So here we have those v2 clusters we had set up exactly how we expected it to, but we still have those v1 clusters that players are still playing on available and still up and running. So we don't interrupt player experience in the slightest. Awesome. Well, we're really excited about Google Cloud Game Servers, and we're really excited about working with customers and developers who are wanting to work on this platform. Most recently, Jam City just pushed out their production workload on top of Agones, World War II, which is an amazing game that you should totally check out. We're really excited to be working with them on their project. I'm really great to have them having a production workload running on Agones right now. So if you want to get started with Google Cloud Game Servers, you can do so right now. It is in public beta and available to everyone. There is a two-phase rollout that is happening here. So phase 1, which is available right now, as I just said, is GCP only and provides basic policy management capabilities. This means that you can run your applications and your games on GKE, and you have basic functionality that'll deal with most of your workloads for auto-scaling and how you want to manage your fleets. Phase 2, which will come in the near future and we're actively working on, will provide more sophisticated and advanced policy management in terms of allocation or time-based scaling, but also will provide multi and hybrid cloud support, which we're also really excited about as well. Because as we've been talking about, sometimes you just need to be able to get these game servers to players in the places that they are, and that having that flexibility is hugely, hugely powerful. So we're really excited about both these developments, and we really want you to get involved. Keep an ear out for all the next phase developments as well. We're definitely going to be looking for people to test out those alpha features that roll out in the future. So if you want to get started, there's a quick start available on the screen right now. Please take the step-by-step process, because then you'll be able to get something up and running on your cluster and being able to play a game. Finally, thank you so much for spending your time with me and learning today about Google Cloud Game Servers. We're really excited about working with you in your games, and we really want to see what you're going to build next. Thank you so much.